Hey everyone, welcome to AV channel. Today we are going to solve the problem number 98, validate binary search tree. So in this problem, given a binary tree, determine if it is a valid binary search tree or not. So we know that in a binary search tree, the left subtree is always having lower numbers compared to the root, and the right subtree is having higher numbers compared to the root. This property holds true not only at the root level, even at the it's at the complete tree level and also at the subtree level. So we need to check whether a given binary search tree is a valid binary search tree or not. So let's discuss about this algorithm. For example, in example 1, so the left subtree, the elements in the left subtree are lesser than the root, and the elements on the right subtree are greater than the root. So this is a valid binary search tree. In this example, the elements on the left subtree at 5 it is lesser, and on the right subtree also it is lesser, so it's not a valid binary search tree. So the algorithm looks good, something like this. So we need to validate both, check validity of BST. First one, check validity of BST at the left subtree, check validity of BST at the right subtree. And the third important thing is, it's not only at that level, but an element, let's say in this example, let's say instead of 4 here, we have 7, and instead of 6 we have 8. Even though 7 and 8 satisfies the property at that subtree level, but overall at the root level it is not satisfying because 3 is still lesser than 5. So it's not only at that subtree level, but it's at overall tree level. We need to make sure that the BST is validated. So check validity of BST at the overall tree level. So in this case, how do we validate this one? So we can validate this. The property for the left subtree is that here you take the maximum of left subtree should be less than root, and similarly on the right side the minimum of right subtree should be greater than root. So let's write the code for this one. So what we are doing, so the initial base case is if root equal to null, then return true. So we will we will solve this one using recursion, right? So we'll maintain two left boolean left valid left is left subtree BST. By default it is true. Similarly we have another flag is right subtree BST, and this also will be true. So if let's say that if root dot left not equal to null, then what we need to do, we need to verify. So we just need to return we just need to get the is left subtree BST. We need to get this and see. This should be a condition of first thing is root dot val should be greater than root dot left dot val, and the second property is at the tree level we need to make sure that for the left subtree the maximum of the left subtree should be less than root. So that's the another property, root dot val is greater than max of root dot left, and this is at that subtree root level, but we need to make sure that this property holds true for, and we need to make sure that this property holds for the remaining left subtree. So we need to validate, we need to move the recursion to is valid BST, we need to move it to root dot left. So I hope this is clear. Similarly, we need to check for right subtree also. In case root dot right is not null, so what we need to do is right subtree BST. We need to validate root dot val is less than root dot right dot val first thing, and root dot val should be less than minimum of, so root dot let's call it as root dot right. So we will be writing these max and min functions in a while. Sorry about this one, and similarly we need to validate the right subtree also should be a valid binary tree. So we need to say is valid BST and root dot right. So here once we get the left subtree and right subtree, so what we need to return, we just need to return the status of left subtree and the right subtree. So is left subtree BST and is right subtree BST. So a lot of people will miss this condition that so we need to validate not only at the root level, but we need to make sure that the min and max on the right and left subtrees should follow the property of BST. So now let's write how to get a minimum value in the BST. So for a right subtree and also for the in case of left subtree, how do you get the maximum value? So public, first let's write for minimum boolean min of tree node left node. Tree node, this is applicable to any node, so we'll just say node. So if here in this case we are not we are actually getting the value, we are calling for the value which is not the node is not null, so we don't need to take care of node value. So here in fact we need to return the integer. So here what we do, we will keep checking if node dot left. So where do we identify the minimum value? So we will identify the minimum value on the left side of the tree. So if node dot left equal to null, then we will simply return node dot left dot val, node dot val, sorry. Yeah, else what we do, we will iterate through the in a recursion we will try to get the minimum value from the node dot left. So we'll simply say return minimum of node dot left. So we keep doing this one. Similarly we will write the function for max tree node and here if we'll identify the max only on the right side of the tree. So node dot right equal to null, then that will be the max. Return node dot value. Else what we do, we will return max of node dot right subtree. So let's run this code. This is working for this example. Let's submit this code. Yeah, so this is 100% faster than Java online submissions. Thanks for watching this video. Please subscribe to the channel.